Hi, my name is Rajesh Valluri and welcome to my video. In this video, I would like to introduce you to Google's Kaggle platform and walk you through a sample competition. If you are a beginner in the machine learning space, or even if you have some experience and are trying to validate your current skills and ramp up new ones along the way, Google's Kaggle is a great place to do that. Google's Kaggle provides you an environment where you could participate in machine learning competitions, solve real world problems, and also win cash and other prizes when you start getting good at it. It is also a great place to build a name for yourself, build your portfolio, make yourself attractive to potential employers, and it brings great bragging rights when you start winning competitions on Kaggle. Most people, including myself, have started using Kaggle using the famous Titanic Survival Predictions competition. As part of this competition, we're given a data set of passengers on board the ship that day. That data set contains information like name, age, sex, marital status, financial status, and among other things. And we are also told whether or not a passenger has survived or died that day. Using this data, which is going to be our training data set, we're going to train a machine learning model and then use that model to predict the survival of passengers on a separate list. That list is going to be our test data set. Obviously, our job is to get as high a percentage of successful predictions as possible. This competition is only an introduction, is meant to be an introduction to Kaggle and its various features, and it does not come with any prizes. However, the learning experience that comes with it is well worth the effort. So let's do it. Setting expectations. Before we go any further, I want to set some expectations and ground rules for this project. Most machine learning models are designed to do better than a human would, or at least match a human would with the same information. So, so let's say if we are trying to predict the house prices of a city, we have certain logical calculations, mathematical calculations that a human being can use and get to a number, and a machine should at least be as good as a human being to be meant as a success, to be considered successful. But that in this case, that's not going to work because there isn't any inherent intelligence to be gained from the data set itself. Let me explain. We know that there is some logic to who might have survived on that ship. Women and children, usually back in the day, were the first to be rescued or provided an outlet out of a dangerous situation. So we know that most of the children and women were let on the lifeboats, and they managed to escape or survive. But we also know that there is some men, upper class men, who either bullied or bribed their way onto those lifeboats and they survived. And also some women didn't want to leave their husbands behind on the ship, and they chose to stay back and die with them on that ship instead of going and saving themselves. So there is a lot of human emotion involved, and there is a lot of chaos. So these rules are not set in stone because it was very chaotic, and there was no rescuing everybody on that ship. So it was very messy. So the data set is messy, and the success criteria is also very messy. So there's no set rules that will dictate whether a person would live or die. And because the model is going to be only as good as the data and only as good as it's going to predict, but it's because there's no inherent logic to how those people survived or died, there's not going to be very high degrees of accuracy. Whereas in the physical world, like for example, if you are trying to predict based on satellite images. If there is a certain mineral in a certain neighborhood, in a certain area, geographical area, the success criteria would be much higher for a machine, because the physical world has set rules which are immutable, whereas human emotion kind of clouds the behavior, drives the behavior, and it's not always logical. So just remember that, when we run this, irrespective of how good our data manipulation and how good the training model is, there's not going to be a very high percentage of success. So just keep that in the back of your mind. Problem types. There are several kinds of um, machine learning problems, and the first step in any project is to identify what kind of a problem we are dealing with. In our case, we have a set of information, and we need to predict whether or not a passenger has survived or died, which means it is basically a classification problem, and in particular it is a binary classification problem, because there's only two classes, 0 and 1, 0 for survive and 1 for die. So once we identify the problem type, we can then decide on what kind of algorithms we can use. There are many pre-built classifiers, and we can test drive a few of them and use the best we think is suited for this problem. Mind you, like I said earlier, there is not a lot of intelligence to be gleaned from the data itself, so most likely one classifier would be as good as any other. In this particular instance, they're all pretty much the same. So we'll test ride a few of them just for learning purposes, and then we'll choose one for the final output. I think we're now ready to go and log into Kaggle. So you can just open your browser and connect to kaggle.com, and then you can just sign in. There is a variety of login options. I think you can use Gmail, Facebook, and also Yahoo for some reason. And anyway, once you log in, and you can look at the platform, and then you can see that there is a competitions tab where you can just find Titanic Survival's competition, and then you can enroll yourself into this. These steps are fairly self-explanatory, so I don't need to walk you through those steps. But once you log in, enroll yourself, and then you should find the code option, and you click on that, and then it will open up the notebook kind of setup where you can start writing your code. And this is where you just need to take a pause, and you take a pause, and then we decide on how to structure our program. Basically, the way I do it is I divide my code into four broad chunks. The first chunk is to import all libraries that we think we may need, and then the second chunk would be to load data and actually manipulate data loading. I'll keep it separate sometimes, because you need to load data a couple times. If you have made mistakes, then you have to go back. So instead of running the whole thing, just keep the load data in a separate cell in itself. And then the most crucial step is to manipulate data. So any data set is always messy. There's always missing fields, missing rows, probably not missing rows, but missing incomplete rows, all kinds of things, mostly redundant data. And we need to do a few things to make sure that all of those are addressed before we can actually train a model. The reason is, if there is missing data, we need to either impute, or find a way to fill those gaps. And if there is cases, in some instances, there is this problem where a particular feature is very high in value compared to the other features. If you prevent that, we need to normalize everything into a value between 0 and 1. So there are things like that. So that's the data manipulation part, and that's the most critical part. So you have to look at your data set, see what kind of features you have. Each column, each field in the data set, like age, sex, marital status, etc., can be called a feature. And not all features are useful, and not all features can be used right away as they are. So you need to manipulate them. So this is called in machine learning space, it's called feature engineering, and it's very, very important for the success of your model. And once you do that, once you have done a significant amount of work on that, then we can proceed to actual training the model itself. So once you have done the data manipulation, the next step is to obviously to identify what kind of model, classifier model you want to use. And once you have done that, and there is one more step before you start the training. There is something called a hyperparameter tuning. Hyperparameter tuning is a fancy word for basically saying uh, my classifier model has a bunch of parameters that I can feed, like options to a function, for example. And there's just no way to humanly enter all those various permutations and combinations to get the best outcome for your data set. Let me explain. If, for example, you have used a classifier which has 4 or 5 parameters, input parameters, most of them can be left as default, but obviously default values are not going to be the best settings. So each of those parameters can be a list in itself. Like you can have starting from 0 to 100 in increments of 5 or something like that. So if there is like 10 or 20 of those, and then each of the other parameters can have 100 of those, 20 of those as well. So that quickly adds up. Those number of combinations will be very high. So instead of manually coding all those values, what we can do is something called cross-validation models. We can use those models. So what those models do is you give them the name of the classifier, and for each parameter you specify the beginning and the ending values and the increments. And then what it does is the cross-validation model takes these inputs and it actually creates all those combinations programmatically, and runs the training and validation on a multiple folds of your training data. So if there is 2,000 records in your data set, it'll be based on your inputs, it'll cut them into 10 or 8 or 100, whatever, and it does the training on a majority of those folds, and then it validates on the remaining of those folds. So if it's 10 folds, you can say train on the 8 folds and test on the remaining 2 folds. And then it does that for all of those various combinations of parameters, input parameters. And then it makes a note of which one is the best, and it will give us those parameters. It says, hey, listen, I tried all of this. These are the parameters that give you the best outcome. And we then take those parameters and we train our data set on the entire training data set, and then use that trained model, obviously, to do to run validation, so to run predictions on the test data set. So this is very important. So this is it. So we're going to do it now. Just follow what I'm doing, and let's see what kind of results we come up with. In this cell, we're going to import the necessary libraries for our program. Some of them are required for loading data and manipulating data, and some of them are the actual classifiers themselves. And you can see that I have also used a bunch of visualization libraries, although I'm not going to use them for this tutorial. In this next cell, which is fairly straightforward, we're just loading data, the passenger data which is provided by Kaggle. Now, this is the most crucial part. Once we have loaded the data, as I explained earlier, we need to make sure the data is complete, and this next cell deals with that part. We are also going to do a bit of manipulation in terms of using some of the features to interpret the values of other features. And also, back in the day, there used to be a lot more salutations than what we have today, and we're going to normalize all of them into a simple set of salutations, using which we then try to ascertain the gender of that person. So, for example, Miss, Mrs., Lady, all of those things mean the passenger is a female, and Master is means the passenger is a child or a boy, that kind of stuff. So this next cell is dealing with all of that stuff. Also, there is such a thing called imputation of values. In our case, we're going to use imputation to fill in missing cells using the median. Using the median. So what that means is, if a set of users, if the median of a particular feature, for example, age for men is around, like most of the men are around 40 years of age, and then a few of them are very young and few of them are very old. If you use mean, that could skew the actual age of those men, whereas if you use median, it will give us a more appropriate approximation of that feature. So we're going to use that as well. So this cell will do just that. In this cell, we are going to actually pick the hyperparameters for the model we're going to use. So how it works is, we let's say we want to use a classifier, and we feed that classifier as a parameter to this cross validation model, which will then give us an ideal set of values for those hyperparameters. As you can see, I have done this for a handful of classifiers just to see which one works best, but pretty much they're all the same. So you can take my code and experiment with the various classifiers just the way I did. So basically, comment out the ones so that you can use that particular model, and then comment the ones, uncomment the ones that you don't want. Uncomment the ones that you want to use, and comment out the ones you don't want to use. So try some of those. Try just to get a feel of the various options available for the various classifiers. And once you get the optimal values from the classifier, from the cross validation model, you use those parameters to train the model and then test the outcome, which you can do here. So at the end of the day, at the end of the training exercise, you get the output from the program, which you can then submit on the right hand side by clicking this button. Unfortunately, when you click this button, I think it produces the file again on Kaggle's environment. So again, it takes a few more minutes to finish, and then once you finish, once it's done uploading those results, it will take you to this page where you can see how you scored on the hidden test data set, and also how you did in terms of leaderboard, which means where you are compared to other people who have also done this project. Looks like we have completed a Kaggle competition successfully, and you can pat yourself on the back because now your name is on the leaderboard. And yeah, so this will be at the beginning of your beautiful machine learning career. And Kaggle, and make sure Kaggle is an important component in your machine learning activities. Hopefully you enjoyed this video, and please subscribe and like, and write to me if you have any questions. Thank you very much.